a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. Having done the last lesson and faced with a problem like this, you would immediately probably think, well, let's do the division, change it to a decimal, and change the decimal to a percent. That's what we've been doing in the last two lessons. But for a change of pace, let's approach this first from another angle. Let's go back to basics. Let's state this question, and really it's a question, in mathematical form. We're really saying 7/8 is what per cent? Now the reason we do this is to emphasize that the purpose of math later, particularly algebra, is when you have a verbal question, can you restate it in pure math symbols, as we did in the last chapter in ratios and proportions. Then in this case, if it's a proportion, you simply solve the proportion. And we won't review that. We'll presume that you can already do that. Then, of course, in this case, if we want to divide the unknown further, we would get the decimal 87.5. So x is 87.5, and this is my percent right here. So we are replacing this whole expression by this equivalent expression, which is a percent expression equal to our given fractional expression. Now, of course, our original way of looking at this is probably faster. Think of this as a decimal, 7 divided by 8. Dividing it, we would get the decimal equivalent, 0.875. But now we recall if we want to change a decimal to a percent, we move the decimal point 2 places to the percent and add the percent symbol. Now this total statement really sums up what we've been doing in this chapter so far. Notice we have a fraction, a pure decimal, and a percent. And the equal signs emphasize that we have the same number in every case. We're simply choosing to write it in a different form. And again, that's an idea always to keep at the back of your mind. Now in this particular lesson, where we want to change a decimal to a fraction to a percent, notice the slick and easy way is simply do the division, change the fraction to a decimal through that division with at least 2 decimal places. Then move the decimal point 2 places to the right, stick the percent sign on, and you're done. Again, to change a fraction to a percent, change to a decimal with at least 2 places. Rounded or else carried out as directed. Then move the decimal point 2 places to the right, that is towards the percent, and append the percent symbol. A common difficulty with this type of problem is simply the matter of following directions. Always read very carefully how they want this carried out. An example, let's say we wish to have this decimal converted to a percent accurate to the nearest tenth of a percent. And the important thing to realize here, it's a tenth of a percent, not just tenth, but tenth of a percent. So if we do this division, we would get this division problem, and beginning to divide, there is a temptation to quit here by saying I have it to the nearest tenth, and that's what they wanted. And the answer is no. They didn't want it to the nearest tenth period. They want it to the nearest tenth of a percent. And a percent is going to be formed by moving this decimal 2 places to the right. So we need at least 3 decimal places to be accurate to the nearest tenth of a percent. So let's go 3 places and a 4th for round off. Accurate tells me I'm going to round off. So dividing this further, we would get so I have a decimal carried out to the nearest 4 places, tenth, hundredth, thousandths, 10,000ths. I wanted this place to realize that I can drop it and round this one down. Now, to change this to a percent, I move it 2 places to the right, and I get 15.6%. See, accurate to nearest tenth of a percent. But to have the percent accurate to the nearest tenth of a percent, I had to have my decimal accurate to the nearest thousandth. 3 places here to get 1 place here, because the first 2 places was to get me the percent to begin with. So again, it's a matter of following directions. We didn't want it rounded to the nearest tenth period, but to the nearest tenth of a percent. Let's try a second one, again emphasizing the matter of being very careful with the instructions. So it's changed to a 2-place decimal with fraction, then to a percent. So as I do this division, this says to only go out to 2 decimal places. So doing that, I get my 2 decimal places and a remainder of 20. But we want that remainder written as a decimal with fraction at the end of those 2 places. So I take my remainder, write it over my divisor, reduce it, and write that fractional quotient against my second place or hundredths place. So now we have a decimal, a 2-place decimal with fraction, and now we want to change it to a percent. So now that we do have a decimal point, we move it 2 places towards the percent or to the right, and stick on the percent symbol. So the fraction 37/80ths and the percent 46 1/4% are in fact the same number written differently. Another example. Change this number to a percent accurate to the nearest tenth of a percent. The word accurate tells me I'm going to round off. It's to be accurate tenth, but tenth of a percent. So we know as we divide this fraction and begin to get a decimal, I need 2 places to get to the percent. Then I need a tenth of that percent. Then I need 1 more place to round up or down. So tenth of a percent means, in fact, decimal-wise, I need to divide 4 places if that's possible. Now what about the 1? Well, this is 1 5/16. As a decimal, we would say 1 and the decimal point becomes the n, so we simply do this division and stick it on against that and. Doing that, we get this. So we have 1 and 5/16, 1 and our 5/16 has become 3, 1, 2, 5. Now we wish to change this to a percent, so we move the decimal point 2 places towards the percent. We get 131 point, but we want it to the nearest tenth of a percent. The digit just to its right is 5 or more, so we drop it and round this up, which gives me this as my percent. Now remember, 1 is the same thing as 100%. So this is more than 1, so our percent equivalent should be more than 100%, and this is. So remembering this sometimes gives you sort of a quick and easy way to check to see if your answer is at least in the ballpark. As a matter of fact, here are 6 more fractions or whole numbers as well to memorize. 1/4 is 25%, 1/2 50%, 3/4 75%, the whole number 1 100%, and also the phrase all of it. If we were to say all of our group went to the fair, we're saying 100% of our group went to the fair. 1.5% is 150%, and 2, which is twice 1, would naturally be twice 100% or 200%. But also very helpful, just remember the word twice. If something costs twice as much as it used to, it costs 200% as much as it did originally. So remember, twice or 200% is the number 2. All of something, or 100%, is the number 1. By using these certain key equivalents, we can check to see if certain answers seem to be at least in the ballpark. For instance, our last problem. This is somewhat more than 1, so we know our answer should be somewhat more than 100%, and indeed it was somewhat more than 100%. So at least if we had made a mistake and had 13%, we would know by this comparison that we're out of the ballpark. That's not reasonable. So again, these are handy things to remember. If you're to be a business, accounting, or bookkeeping major, then you'll have a list of about 12.5 fraction to percents, which ultimately must be memorized. Let's take what we've just done and then backtrack and review the last 2 lessons and begin to tie the 3 together, because a common error made by students at this point is to become somewhat confused about what is happening at any one moment. To begin with, if you're going from a decimal representation to a percent, we had stated that the key was the word to a percent, and that you simply move the decimal point 2 places to or towards where the percent is going to be, and then you just stick the percent sign on. Now remember, percent means hundredths, so we're saying roughly 13 hundredths, and roughly we do have 13 hundredths here, don't we? So always check back into the ballpark, as we've been calling it, to see if this seems reasonable with what we know about what percent means. That is, percent means per hundred. Okay, so if you have only 1 decimal place, or even less, the key still is you move 2 places towards the percent. So you actually move it 2 places towards the percent, and if in so doing you create extra places, you fill those places with placeholder zeros and stick that percent on. Again, checking our ballpark thinking. 200 means 2. 230 means more than 2, and this is indeed more than 2. Again, if you're changing to a percent, you move the decimal point 2 places towards the percent and stick the percent sign on. Now if you get an unusual number, this is quite a small percent, then so be it. The rule to always move the decimal point 2 places towards the percent is inviolable. So never change that rule just because your results look strange. That's just the nature of your results. Okay, so going from decimal to a percent, the key was to move towards the percent. 2 places, of course. And if you had a percent to begin with, and you wanted to go back to the pure decimal. Now note I keep saying pure decimal because in fact these percents have a decimal already along with the percent, don't they? Including this one, because remember whole numbers always have a decimal point to the right end. It's just that we don't bother writing it. On this problem we said the key to help remember this was that you really want to get away from this percent. So concentrate on the thought that I want to get away from the use of this percent. Then in that case we drop the percent, move it 2 places away. Of course that's just the reverse of what we did previously. Again, drop it, move it 2 places away, and if in so doing it you create extra places, you insert placeholder zeros, and then not to be concerned because it looks rather strange. It's a terribly small number. That's just the way it comes up, and this is the correct answer. And again, if you want to get away from the use of the percent, you drop the percent and move it 2 places away. I've created an extra place, so I insert the placeholder 0, and of course there is no percent. And finally, our current lesson, changing fractions to percents. Since we've already covered changing decimals to a percent, and prior to that, fractions to decimals, we simply go through decimals first, and then from decimals to percents. And to change to a decimal, we just remember that this fraction bar is another way of saying divided by. So we essentially have a division problem. 7 divided by 13. But many fractions, when you change to decimals, will in fact be non-terminating decimals. That is, they're going to go forever. So at some point they must tell you where to quit, whether you are going to round off at a designated spot or whether you're going to have a fraction with that decimal at a designated spot. But remember that if we're going to go from this decimal to a percent, ultimately we're going to move the decimal point 2 places towards the percent. There's 2 places that we need. So always when you're dividing, you divide at least 2 places, decimal places, so that you can move the decimal point those 2 places to go to a percent. But more specifically, watch for the directions, because usually the directions, depending on what you're going to use this number for, will specify where they want you to stop. Let's say that you were requested to round to the nearest hundredth of a percent. Here we cautioned you that you not stop in your thoughts at the word hundredth, because that would tell me to stop here and round here. But they want not the nearest hundredth decimal-wise, but the nearest hundredth of a percent. So I will have to move the decimal point 2 places to get to a percent, then 2 more places to get to the nearest hundredth of a percent, because the percent decimal point will be here. So we go 1 more place to decide, do I round up or down? So in order to have this accurate to the nearest hundredth of a percent, I'm going to have to perform this division out 5 places. Not the 2 that a beginner might think of, because this is the nearest hundredth period, the nearest hundredth of a decimal. But we want the hundredth of a percent that it's going to end up being. So doing this division, we get this decimal equivalent of this fraction. Changing it to a percent, I move the decimal point 2 places towards the percent. So it's going to end up here at 53.8. But I want it rounded to the nearest hundredth of a percent, so the digit just before that is 6, which is 5 or more, so I'll add up and make that 85. And since it is a percent, I stick the percent symbol on to indicate that. So 53.58%. Now let's see if this seems reasonable. That is what we've been calling in the ballpark. 50% is half. So 53% is just a trifle over a half. And 7/13 is a trifle over a half. So this at least seems reasonable, assuming that our division was done properly. Here's a very real problem I extracted from a business document. This actually was needed in a business transaction. We want to change the fraction 3/17 to a percent, but a percent that has a fraction at the 10th of a percent. This is involving everything, the decimal, percent, and fraction. So we start off first concentrating on the fact that I wish to change it to a percent, which means I'm going to perform this division. So let's actually begin to do that, then we'll think our way further through this to see how far into this division I go. So let's actually do this rather slowly together so you can actually see the process and thinking that takes place. So this reads 3 divided by 17. I'm going to insert quite a few zeros. Now to find out how many zeros, that is how far must I go through the division, let's just put in 4 or 5 to begin with, hoping we won't have to do all of them. But then reminding ourselves that we're going to ultimately change to a percent, which means that the decimal point is going to move 2 places towards the percent. But then this says I want a fraction, which means at some point I'm going to take my remainder, write it over my divisor, but the question is where? And it says at the 10th of a percent. So if my decimal point is going to move from here to get to the percent, then one more place will give me the 10th of a percent. And at that point, I want to quit and take the fraction and have a fraction at the 10th of a percent, which will actually be at the thousandth of the original decimal. Do you see that? It can be very confusing if you're not thinking very, very slowly, carefully, and methodically. So now beginning our division, 17 into 30 is 1. 17 into 130 is 7. That's 49, carry the 4. That's 11. 17 into 110 is 6. That's 42, carry the 4. Now my remainder is 8. So I'll write the remainder over the divisor. Now I've changed this fraction to a decimal with fraction at the nearest thousandth. Now changing that decimal to a percent, I move the decimal point 2 places towards where I want the percent to be, and I get 17.6 and 8/17, and because I moved it towards the percent, I stick the percent sign on. So I have a percent, but it's a percent with a fraction at the nearest tenth. Now again, let's check our ballpark reasonableness of this. 17% is a little bit more than 10%, and 10% is 1/10. And this certainly is a little bit more than 1/10. So that at least seems to be within reasonable magnitude. Did you follow this? If not, you might want to rewind this tape and watch that portion once again. Let's say that all of that was somewhat confusing to you, but you were good at solving proportions. Then let me show you how knowing how to solve proportions can help you make all the decisions we made more easily, perhaps. First, restate this question that I'm using words for here in mathematics. that is, as a proportion. Now, what do I mean by that? Well, watch. What are we really saying here? We're saying 3/17 is what percent? Well, let's say that. 3/17 is what? And what in algebra is always a variable, something we don't know, so we use a letter to stand for that temporarily. But how do we say percent? Well, there's my per, and there's my cent. 3/17 is what percent? And I know that when I get done, this will be a percent because that's exactly what I'm asking. Okay, so now we simply solve the proportion, which we've been reviewing the last couple of lessons. So we know that we would multiply these two, which obviously is 300, then divide by 17, and my answer will be in percent form. So notice as I divide this, the decimal point now is here. I'll move it straight up, and that's going to be in percent form. So let's just go ahead and stick the percent sign on it. But now the problem says it wants me to go to the nearest tenth of that percent, so I'm going to go one more place, and then give my remainder as a fraction at that tenth of a percent. So I just follow through on what the proportion really is directing me to do. Now it's 17 into 30 again, and see, I'm just repeating my previous work. And I'm all done. When you begin to think in mathematical sentence, and in particular, in this case, proportions, you don't have to worry about all that remembering of rules we used here. You can actually state the problem mathematically, and the mathematics itself will direct your attention and your moves. Like this one, write 5/6 as a percent accurate to the nearest tenth of a percent. This is telling you what they want. This is merely telling you how accurate they want it. So I want 5/6 is what percent. And if you're allowed to use a calculator, and if you know how to solve percents, you're going to multiply this, which is 500, divide by 6, and that is the percent answer, but they want it accurate to the nearest tenth of a percent, which this is. This is percent form already. So we'd say 83 point, and there's 0.33, so the digit just to the right of the tenth is less than 4, so I round down, so this is 3, and it's already a percent, so I simply stick on the percent to indicate this. Easy? I hope so. This is your host, Bob Fennell. We'll see you at the next lesson.